Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, I am going to discussing about network software. First, let us see the overview of today's session. Today, we are going to discussing about what is network software. Then we will be discussing about these different categories of network software. Those are protocol hierarchies, that is layer structure. And next, we will be discussing about design issues of the layers. And next, we will be discussing about connection-oriented and connectionless services in network software. And next, we are discussing about service primitives in network software. And finally, we are going to discussing about the relationship of the services to the protocols in network software. These are all categories in network software we are discussing in today's session. First, let us see what is network software. Network software mainly used for the design and implementation, operation and monitoring of the computer networks. At the same time, the traditional networks mainly for it is the hardware based and also it is software embedded in that. At the same time, the advent of this software network, software defined network, that is SDN, this software mainly separated from this hardware, that is more adaptable to the ever changing network nature of the computer network. This is about network software. Let us see the categories of the network software. These are the 5 categories of the network software. First one is protocol hierarchies, that is layer structure. And next one is design issues of the layers, that is second one. Third one is connection oriented and connectionless services in network software. And next one is service primitives in network software. And finally, the relationship of the services to the protocols, that is in network software. First, let us see protocol hierarchies in network software, that is layer structure. First, what is protocol here? Protocol is nothing but set of rules. These set of rules mainly for communication between the devices. Mainly for communication between the devices, we are going to use set of rules, that is protocol. Coming to hierarchy, what is hierarchy? Hierarchy mainly for transferring the data. This hierarchy mainly for transferring the data from one place to another place. One place to another place. One place to another place. For transferring the data, we are going to use hierarchies. Transferring the data from one place to another place by sequencing, that is hierarchy. At the same time, these protocols mainly outlines the what, how and when of that about the communication. Means what about the communication, what type of communication is going on between the devices, how the communication is going on the devices, at the same time when that communication is going to be happen between the devices, that is about the protocol. And next, this protocol mainly talking about 3 aspects. Those 3 aspects are syntax, semantics and timings. These 3 aspects in protocol. First, what is syntax? Syntax is nothing but mainly talking about format of the data, means which format the data is going to be sent and received. That is about the syntax. Means that may be document file, that may be PPT, that may be PDF, anything that is talking about the format of the data, which format. And next one is semantics. Semantics is nothing but the meaning of each section of the bits of that particular data that is going to be transferred. Meaning of each section, that is semantics. And coming to timing, it is talking about the at what time the data is going to be transferred. At the same time, what is about the speed? It is also talking about the speed. At what speed the data is going to be transferred. That is talking about the timing. These 3 aspects we are considering in protocol. And next one, coming to protocol hierarchy, that is layer structure. This is about the layer structure in protocol hierarchy. It is having the 5-layer architecture, means I already told OSI reference model is having the 7 layers. Those are application layer, presentation layer. These are all the different layers are there, right? 7 layers. These 7 layers, that is considered as layer 5, 4, 3, 2, 1. These are all the different layers. These are all nothing but, these are all the stack of layers. Means stack is nothing but one on the top of another layer. Means one on the top of another layer. That is stack of layers. That is a protocol hierarchy. Each layer is having, each layer, these number of layers and their names, these are vary from the network to network. Means whatever data is transferring from one layer to another layer, the data number of layer means data name also going to be different. And also each layer is having their own functionality. Means each layer. So this is 1, 2, 3, 4. These are the different layers, right? Each layer is having their own functionality, and also each layer is having their specified protocols also. This is called as stack of protocols. So coming to this diagram here, this is the host 1 and this is the host 2. Here 2 hosts are there. So inside the host, it is having different layers like layer 5, 4, 3, 2, 1. These are the different layers in. Suppose it is considered as one device and this is considered as one device. 2 devices means this is one host and this is another host. These 2 devices. Inside the devices, it is having the layers like 5, 4, 3, 2, 1. These are the different layers inside the device. And coming to between the devices, in between these devices also there is a communication like protocol. Layer 5 protocol, layer 4 protocol, layer 3 protocol, layer 2. These are all the protocols, right? It is in dotted lines. It is a virtual communication. It is a virtual communication in between host to host, one host to another host. The communication is virtual communication inside the layer, inside between the layers. So here in between the layers, like this, between the layers, it is a solid line, right? This is the solid line. It is called as physical communication. This is a physical communication and this is solid line indicating the physical and this dotted line indicating the virtual communication. Physical line, physical communication inside the host and virtual communication between the host. That is the main difference. At the same time, it is having this solid line indicates the interface. So layer in between layer 4 to layer 5, layer 3 to layer 4, there is an interface. This solid line is called as interface and this virtual line is talking about the protocol. Which protocol using in that particular layer? Means from layer 4 in host 1, layer 4 is connected to in host 2 layer 4. That is one particular protocol through this particular protocol. That is layer 4 protocol. At the same time, layer 3 in host 3, layer host 1, layer 3 in host 2, those are communicated with layer 3 protocol. That is virtual communication. So, this all layer in host 1, all layers, host 2, all layers are communicated to some physical medium. This physical medium main aim for what purpose means, suppose whatever data is sending from host 1 to host 2, whatever data that may be PDF format, document, anything, whatever data is coming, right? 50, these are the different formats. These all are communicated through this physical medium only. What is the main aim of physical medium? Whatever data is sending from this host 1 to host 2, that can be transferred in the form of binary. Means computer understandable language is binary only. Means like zeros and ones format only. Whatever data is there, that is going to be transferred, converted in the form of zeros and ones, and again it is transferred to the host 2. That is the main work of physical medium. And coming to, so here the diagram is mainly having how many layers here? Layer 1, 2, 3, 4, 5. Here it is having 5 layers. At the same time, it is the communication in between host 1 and host 2. It is the communication in between host 1 and host 2. At the same time, whatever data is there, that is passed to the number of layers. Suppose if I want to send some data from here, say host 1 to host 2, it is passed through all the layers. Whatever layers are there in that particular host, it is passed through all other layers. And virtual communication is in between. What? Virtual communication in between the host and host, that is dotted lines. I already told this is the dotted line indicating the virtual communication, and physical communication solid lines. That is solid lines indicating what? It is the interface. Okay. So here through this physical medium, actual communication is going to be occurred. Main aim of physical medium is converting the data from in the form of binary. Actual communication is started from the physical medium only. The layers at the same level. So here is level 1, layer 1 and layer 2, these 2 layers. So layer at the same level are commonly known as peers. So layer 1 here in host 1, layer 1 in host 2, these 2 called as the peers in that particular protocol hierarchy. So these peers basically having the set of communication protocol. See, this is one peer, right? This is peer and this is one peer. These 2 are called peers. These 2 are communicated through this particular protocol, that is layer 1 protocol. And also here interface is going to be present. I already told in between the layers we are having the interface, that is solid line. Solid line indicating the interface. Interface main aim is for what purpose? to explain the services provided by the lower layer to the higher layer, means layer 1 indicating layer 1 is providing the services to the layer 2 and layer 2 is providing the services to layer 3 and layer 3 is providing the services to the layer 4. Like that interface is going to be work. So, between each pair of adjacent layers, we are going to use interface. This interface mainly for primitive operations and services, mainly for performing some operations and services in between the layers from lower layer to upper layer. That is about interface. And coming to network architecture. What is network architecture in this diagram? It is a set of layers and protocols. This total is called as a network architecture. It is having the layers at the same time protocols. This set of layers and protocols, we call it as a network architecture. And coming to protocol stack. What is protocol stack here? So, a list of used by certain system and one protocol per layer is called protocol stack. See here in this diagram, each layer, some of in host 1 consider as layer 4, in host 2 consider as layer 4. Each layer is only having particular protocol, that is one protocol per layer, that is called as protocol stack. These are all comes under protocol hierarchy in network software. And coming to next one in network software is design issues of the layers. What are the design issues of the layers? Means while transferring the data from one device to another device, there may be chance of some design issues. What are the main design issues here? First one is reliability. What is reliability? Suppose if I want to send the data from one device to another device. So suppose I am sending the data 1 MB data from this device. This is the sender and this is the receiver. If I want to transfer the data from sender to receiver, I am transferring the data 1 MB, means exactly receiver also receives 1 MB data only. That is reliable. That connection is reliable connection. The data, what exact data, total data is going to be transferred to the receiver. So, if suppose the receiver is received 12 KB data only, means there may be loss of data. That is not a reliable data. That is nothing but reliability. And coming to scalability, this is also one of the design issues in network layer. Scalability is nothing but everyday technologies are going to be changed. New technologies are coming. Suppose if we applied new technologies, means added for that added components, there may be chance of incompatibility issues. To overcome that, we are going to adopt all the additions and alterations to that particular software. That is nothing but scalability, means any technology also we can adopt, means that is compatible to any software. That is about the scalability. That is the one of the design issue in network software. And next design issue is addressing. Suppose take a large number of computers. So, number of computers are there. Here number of computers are there. Number of computers are there. These computers are sending number of messages. Suppose 1000 messages are sending at a time. Means these messages exactly how the receiver is receiving, exact receiver only through this particular address only. Means each message is having the sender and receiver address. That is the addressing of main design issue in network software. And coming to error control. This is also one of the design issue. Error control means whenever we are sending the data from one device to another device. Suppose whenever we are sending the data from one device to another device, there may be chance to come errors also. So, these errors, how these errors are going to be detected? That may be error detection. For that, we are going to use error detection. And after detecting the error, means where exactly error is there in that particular channel. Afterwards, after detecting the error, we have to correct those errors. That is nothing but error correction. These two comes under error control. These we will discuss in upcoming lectures. That is error detection and error correction. That is also one of the design issue in network software. And coming to flow control. What is flow control? So, for this, suppose consider two devices. It is one device, this is one device. These are the two devices. Flow control means, suppose this capacity of this device, coming to capacity, per minute, this particular device per minute, it will send 100 messages. 100 messages it will send. But the receiver, this is the sender, this is the sender, and this is the receiver. Suppose the capacity of the sender is 100 messages per minute it will send. But receiver, it will receive only 10 messages per minute only. So, per minute it will send 100 messages to this particular receiver. Again, next minute it will also again send 100 messages to that particular receiver. But the capacity of this receiver is only 10 messages, means it is there may be a chance to data loss also. Because the capacity of this particular receiver is only 10 messages per minute, but the capacity of this one is 100 messages. There may be a imbalancing the flow. That is nothing but flow control. It means we have to focus on the flow control mechanism that needs to be implemented. So, to control overflowing of the data, that is flow control. This is also one of the design issue in network software. And next one is resource allocation. It is also one of the design issue in network software, means where the resources, means how to provide the services in the form of network resources, that is to the end users. How you are going to allocate and deallocate the resources to the processes is nothing but resource allocation. And next one is the statistical multiplexing. It is also one of the design issue. So, it is mainly to allocate, it is not feasible to allocate the dedicated paths for the each messages while it is going to be transferred from source to destination. That is nothing but statistical multiplexing. And coming to next design issue is routing. What is routing here? Routing means it is providing the multiple paths from source to destination. That is nothing but routing, means suppose here is this is the source, this is the destination, this is the source and this is the destination. If I want to reach, means suppose if I want to reach from Hyderabad to Vizag, I want to reach. So, this is one route and this is also another route to reach from that particular place, means multiple paths are there to reach that particular place. That is nothing but routing. Exactly which path we have to select to reach that particular destination, that is nothing but routing. So, in terms of cost and time, we have to check the cost to reach that particular destination, and time also matters here. Based on that, we have to use some routing algorithms in the network system to select the best, means optimal path for that routing. That is comes under routing. This is also one of the design issue in network software. And coming to security. What is security here? In nowadays, security also matters, right? Every way, means unauthorized access may be a chance to prevent that. We are going to use security also, that is through the authentication and cryptography. We are providing the security to the networks. This is also design issue in network software. These are all the different design issues in network software. And coming to next category is connection oriented and connectionless services in network software. First, we will see connection oriented service. What is connection oriented service? I am saying about connection oriented, means there is a connection like physical connection between the devices. So, here based on the telephone system, this connection oriented service is going to be defined. So, for example, telephone system means to talk someone, we have to pick up the phone, then dial the number, then talk, then hang up. Like this is the process, means before going to that, first we have to communicate with the device. So, here see this picture here, source is there, destination is there. So, if I want to send the data from source to destination, first I have to communicate with the device, means I have to select the route, which route I have to select to send the particular data. That is connection oriented. This connection oriented service first establishing the connection before sending the data. First we have to communicate, we have to establish the connection between the source and destination. First establish the connection, then only we can transfer the data. That is connection oriented service. Means here it is mainly talking about there is a handshaking method. It follows handshaking method. Handshaking is nothing but, so after establishing the connection, the destination gives the acknowledgement to the sender, means I have a connection with you, means it is giving some acknowledgement to the source. Then it will send the data. That is nothing but handshaking, means whether the source will check after sending the data, that source always check whether the data is received by the destination receiver or not. That is nothing but connection oriented service. At the same time, all packets belonging to the same message that follows the same dedicated path only, means Here take this example, here 4321 is there. It will select to R1, R2, R4, this path only. Whatever data is going to be there, it will already establish the connection before only. After establishing the connection only, the data is going to be sent from source to destination. Means there is a dedicated path between the source and destination. That is connection oriented service. And in this connection oriented service in network layer, mainly it is talking about the coordination in between the source and destination and all the routers. There is a coordination between all the routers. That is about source and destination in network layer. At the same time, in transport layer, it is talking about end to end. It provides the service source to destination, means from source end to destination end, whether the data is going to be received or not. That is talking about source end to destination end, whether the data is going to be received or not. That is talking about the transport layer. And next, this connection oriented service can be implemented the flow control, error control and congestion control. I already told flow control is nothing but the both sender and receiver speed must be same. At the same time, error control, if any errors in between while sending the data from source to destination, we have to detect the error and correct the error. That is nothing but the error control. And coming to congestion, congestion is nothing but the traffic. Whenever we are traveling some messages between these particular routers, there may be a chance to traffic also. How those traffic is going to be controlled? These all also implement in this connection oriented services. This is about connection oriented services. And next one is connectionless service. What is connectionless service? That is also called as datagram service. It is mainly based on postal systems, postal services. In real time, postal card, take postal card is nothing but letter. We have taken one example, letter only. Letter, in that letter we are writing the sender address, at the same time receiver address. Both we are writing sender and receiver address. But sender send the data, means sender sending the data. But it will not bother about whether the receiver is received and not that particular data. That is about connectionless service. So here there is no handshaking. Handshaking is talking about sender is sending the data, but whether the receiver is received or not, the sender is don't know. That is nothing but the no handshaking. So here this connectionless service mainly talking about the same message, whatever message is there, that is 4321 in the form of packets only, right? Whatever data is there, that is 4321. That is same message can be divided into different formats, and that is independent entity. And each packet carries the source and destination address. So here here 4 packets are there. 1 packet, 2, 3, 4. 4 packets are there. So 3 is selected this route, and 2 and 1 is selected this route, 4 is selected this route. Each packet is selected different route to reach the destination. At the same time, each packet is having their source address, at the same time destination address also. That is connectionless service. At the same time, this connectionless service, each packet of same message may follow the different route. Means each packet can take any route. Whatever route packet want, that will take that particular route. That is connectionless service. And next, these connectionless service packets are routed based on the destination address. So finally, the main aim of these packets is to reach the destination that can select any route. These connectionless service in the network layer, it selects the different route for the different packet belonging to the same message. It is having the same message, but it will select the different routes in the network layer. While coming to transport layer, it is talking about the independency between the packets. Means all packets are going to be independently traveling. That is about the transport layer, to send the data from one end to another end. Means source to destination. In connectionless service, we can't implement the flow control, error control and congestion control. In connection oriented, all we can implement flow control, error control and congestion control. While coming to this connectionless, we can't implement this flow control, error control and congestion control. This is about the connectionless service in the network software. And next, what is service primitives in network software? This is the next category in network software. Service primitives. Primitives is nothing but operations. Primitives is nothing but operations. What are the main operations in this network software? Service operations. So each protocol communicates in the layer architecture. I already told different layers are there in OSI reference model. open system interconnection reference model. It is having the 7 layers. Each layer is having their own protocols. The same time, these are communicates in a peer-to-peer manner. These all layers are communicated in the form of peer-to-peer only. The same time, a service is formally defined as it is a set of operations. Those are available to the user process to access the services. That is service operations. The communication between the adjacent protocol layers means within the same communication nodes. Those can be managed by calling functions. These calling functions are nothing but the primitives between the layers. So, there are the various types of actions. Those are going to be performed by the primitives. Examples of these primitives are connect, data, flow control, disconnect. These are all the different primitives in the service operations. Let us see what are the service primitives are there in. This can be also divided into two types, that may be connection oriented service primitives also there. Connection oriented and connectionless. Connection oriented also there, connectionless service primitives also there. We will see what is connection oriented and connectionless service primitives. First, we will see connection oriented service primitives. Connection oriented service primitives are listen, that is for block. It is a block waiting for an incoming connection, and connect. This can be used for establishing the connection with a waiting peer. And next one is the accept. This primitive can be used for accepting an incoming connection from a peer. And next one is receive primitive. This can be used for waiting for an incoming messages. And send, that can be used for sending a message to the peer. And disconnect, finally terminating the connection. These 6 Ps, these 6 primitives we are using in connection oriented services. While coming to connectionless service primitives are unidata, that mainly for sending a packet of data. And coming to facility and report, these two primitives can be used for delivery statistics. Those are based on the performance. We are calculating these primitives, facility and report. Coming to this picture, it is talking about the service primitives. It is a client machine and this is a server machine. And it is talking about the system calls. It is having the system process. Means it is a client machine. So, it is a system calls. Server machine is talking about the process. So, it is also having kernel, protocol stack and drivers. It is also having kernel, protocol stack and drivers. So, this is called as a operating system. It is a client process. And first, client send the request to the server. And next, server give the accept the response. And again, client send the request for the data. And again, server will reply to the client machine for replying the data. And next, client send the request for the disconnect. And server will disconnect from that client. This is the process of service primitives in this client server model. And next one in network software is the relationship of the services to the protocols. This is the 5th category in network software. So, the relationship of the services and protocols. What are the services to this particular protocol? A service is nothing but set of primitives. Primitives is nothing but operations. These all operations that are the layer is provided to the layer above it. Means these operations from layer, this is the lower layer and this is the starting. Here is the lower, from lower to upper. That is one layer to above layer. That is, we are providing some operations. That is a service. These service mainly depending what operations that layer is prepared from that on behalf of its users. Means this mainly talking about the what operations of that particular is going to be performed that behalf of that particular users. The same time, this services is related to the interface in between the two layers. So, mainly this is the service. Interface in between two layers is nothing but the service. With this lower layer is being to the service provider to the upper layer. Means layer k minus 1 is providing the services to the layer k and layer k is providing the services to the layer k plus 1. Here also layer k minus 1 is providing the services to layer k and layer k is providing the services to layer k plus 1. That is providing the services to lower layer to upper layer. And next, protocol. Protocol is a set of rules. So, here is protocol between the layer k to layer k, peer to peer. We are using protocols. That is set of rules. It is related to the implementation of the service. For implementation purpose, we are going to use the protocol. This is for implementation of that particular service. such is not visible to the user. Means it is a virtual communication. Because it is a virtual communication, it will not visible to the user of that particular service. So it is a physical communication, so it will visible, but it is a virtual. So that is about the relationship of the services to the protocol. And let us see the summary of today's session. First, we will be discussed about network software. Next, we have seen what are the protocol hierarchies in network software. Next, we have seen design issues of the layers. Next, we discussed about connection oriented and connectionless services in network software. And next, what are the service primitives we are using in network software, like connection oriented service primitives, connectionless service primitives. And next, we have seen the relationship of the service to the protocols in the network software. Those all we discussed in today's topic, that is about the network software. Thank you.